Hello and welcome to a tutorial on modal analysis using ANSYS Workbench 18.1. In this tutorial we're using ANSYS to solve for the natural frequencies and mode shapes of a plate that is going to be clamped on all four edges and the plate is flat. So to start with, I come here to my toolbox and I scroll down until I find my geometry. And when I left click on my geometry, I get a green dashed line up here in my project schematic. And you can see that when I drag my cursor up to there, the green dashed lines turn to red. When that happens, I'm ready to let go with my left mouse button, and that will create my geometry file and my geometry tree where I can now go in and edit and change my geometry. If I've already created a geometry in another CAD package, I can simply right click on the second line there, right click on my geometry, and it takes a second, but when it comes up I can then see where I could import a geometry, where I could browse for the file or pick one of these where I have recently done some analysis. Since this is a standalone tutorial, I'm going to go ahead and create the geometry in SpaceClaim. So doing that, I'm going to double click on geometry, and when I do, you'll see that this ready down here with the green lights, meaning that it's ready for the next command, will turn to a red dot saying, okay, I'm starting SpaceClaim, the geometry modeler. So this takes a minute to come up. While it's coming up, I'll go ahead and pause the video. So this is how SpaceClaim comes up. I go ahead and close this dialog window. And the first thing I like to do is change the sketch plane. You can see here that the default sketch plane is in the X and the Y directions. I like to sketch in the XZ, so I will right click on the grid, scroll down till it says select new sketch plane, left click on that, and now you can see as I move my cursor around, it highlights the different sketch planes. So I'll move the cursor around till I'm in the XY plane and the XY plane's highlighted, and then I'll left click and that selects that sketch plane. I can now come down here and click on this Z arrow, and that will put me looking right down the Z axis and directly into the XY sketch plane. I'll come up here then to the pencil and the grid, and this is meaning that I'm in sketch mode. You can see that if I hold the cursor over that, it brings up sketch mode, and I can hit the F1 key and it would bring up a help on that sketch mode icon. We don't need that, so I'll go ahead and close that out. Now I want to build a rectangle, and so I'll scroll over here until I hit the rectangle. I'll click on the rectangle, and this has a nice feature where it will define the rectangle from the center, so I'll go ahead and click on that. Now I'll come over and left click the center of my rectangle and drag it out to the dimensions that I want. I can either drag it to those dimensions or I can key those dimensions in. And the blue highlighted dimension is the dimension where if I enter a number, that's where that number will go. I'll enter in this first dimension as 300 millimeters, and then when I hit the tab button, it will move to the next dimension, and I can enter that dimension in as 200 millimeters. And you can see now that I have my rectangle. I could go and build another rectangle. I could take a circle out of that and do whatever I needed to do. If I want to change the units, and I don't want these units to be in millimeters, I come up here to File, and then I go down to SpaceClaim Options, and I click on SpaceClaim Options. And this will bring up a dialog window where I will be able to pick units and be able to change those units. So here you can see I'd scroll down to the units, and I could change the metric to imperial, or I could leave it as metric but use my default as meters and change the length. You can also change the units just for this document, or in this drop down you could set it to change it for all new documents. Since I'm using the defaults, I'll just go ahead and cancel out of this window. Now we're ready to make this plate a three-dimensional plate. Right now it's just a plane. When I come up here and I click on the pool under the edit tab, now you can see that it's still a plane, but it's still just a two-dimensional plane. But you can see my cursor now has arrows going both ways, where if I click with my left mouse button on that yellow face, I can drag that plane either direction and turn it into a three-dimensional geometry. If I don't like what I've been doing so far, I'll simply hit escape, and that'll take me back to that plane. So I'm going to pull this in the negative Z direction, and I'll pull it, so I left click on it, I'll pull it back, and I'll pull it back 5 millimeters. So leaving my mouse button clicked, I can go ahead and enter in the 5 and then hit enter, and it will make my plate 5 millimeters thick. So that's my geometry. That's all I need to do there. I'm ready to close that geometry and start to go through the model development and do the modal analysis. So I'll minimize that window. I'll come back to my toolbox window and scroll up until I hit modal, and I'll left click on modal analysis, and you can see all the green boxes that show up. But I need to make sure that I come and I hold my mouse button over the geometry and then let those boxes turn red. And when I do that, that will connect my geometry now to the modal analysis module that will come up over here. Now I'm able to go in and change my engineering data if I want to. The default is structural steel. I'm just going to leave it as structural steel, and if you want to look at the engineering data and how to change that, you can go ahead and look at a different tutorial. You can see that this connected my geometry to my modal analysis module. I have a green check, meaning everything came through okay. I'm ready to go ahead and start to build my model, so I'll double click on the model, line number 4. You can see that it is now starting mechanical, and again this takes a few seconds, so I'll go ahead and hit pause while ANSYS Mechanical is coming up. So ANSYS Mechanical has now brought the model up. By default it brings the model in, the current model that you have in SpaceClaim, it brings it directly into your viewing window. Over here in this outline, this is the process that we need to follow to develop the modal analysis model. It's best to just start at the top and work down through the tree. Under model, I can see that it's brought in my geometry and I have a green check. If I click on the plus, I can see that I can click on this geometry solid menu item, and it turns that geometry part green and selects it. If I had multiple plates in here, for example, I would have several of these and I could look at those different plates. Everything looks fine there. I'll go ahead and minimize that. Coordinate systems, I'll just use the default global coordinate system, which is the Cartesian coordinate system. And now I'm ready to look at mesh. So if I left click on the mesh, it brings up the details of the mesh, and this is where I can look at the sizing. If I click on the plus on the sizing and scroll down, it has various settings that I can change on the sizing of the mesh. The first one that I'm going to change is this size function, and instead of adaptive, I'm going to click the drop down over here with my left mouse button and click on uniform. I'll go ahead and leave it as a coarse mesh and see how coarse that is, and maybe need to refine it after that. So I'm ready to come up and hit update on the mesh, and this can sometimes take a few seconds depending upon the size of your structure and the number of elements. But this meshing icon pops up, you can see the progress, and then meshing's done. You can come over here and look at your mesh, and for this model I'm going to go ahead and let that mesh be sufficiently fine for the analysis that we'll be doing here. You can see that I got a green check up on my mesh. Then it's done, and I'm ready to move to my modal. And this is where, under modal here, where you will develop your model. So if I click on modal, you can see that my toolbox up here and the settings that I can changes from when I'm up here on model. These all have to deal with the model. When I come to modal now, this is the modal part of my model. So I'll come here to supports, and I'll click on supports, and I'll go ahead and fix all 4 edges. So I'll click the fixed support, and now down here you can see that geometry is highlighted, and I'm going to come and pick the edges of this plate. And to do so, I'll roll in and out with my mouse button. With my middle mouse roller, I can zoom in and out. I need to pick my selector up here. You can see that I want to make sure that I'm selecting faces. If I wanted to select an edge, I'd come there, and now when I pick these different, move my mouse around here and pick these different lines, it's going to select those edges. This would let me pick points. I want to click on faces and put a boundary condition actually on that face. So I'll click the face. Now I'll have to move my geometry around a little bit, so I'll zoom in and out with my middle mouse roller, hold down my middle mouse button, and I can rotate my body. When I control left click, it will let me select multiple components. And so I'll control left click these edges, zoom in, control left click again, and I got one more edge, control left click, and I have now all my edges selected. And I'll go ahead and click apply, and you can see that it applied that fixed support on these 4 edges. In modal analysis, it's independent of the forces and the loadings, and so I don't need to apply any loads on my structure, and I'll just use the default inertial loading that's due to the density in the steel that was selected as the default material. So now I'm ready to come down here to analysis settings, and by default it will extract the first 6 modes. If I want to increase that, I simply click on that number and I can increase that up to 10. You can see the default for the solver controls is no on damped. If I wanted to do a damped modal analysis, I'd click yes there, and then I could come down on my damping controls, and I could input my alpha and my beta for the stiffness and mass coefficients, or I could come and click on, instead of using a direct input, I can use the damping versus frequency. And in this case, I enter in a frequency and I enter a damping ratio instead of a damping coefficient. We'll talk more about damping in class, but those are the basics of how you select damping for a modal analysis. I'm going to go ahead and do use the damped solver, and I'm going to use the program selected solver type, but I'll leave my damping coefficients as zeros. Pre-stress, you have to do a static analysis if you want to do any pre-stress. In this case, we're not going to pre-stress our plate. So I'm done for the modal component. I'm ready to go to the solution, and I need to determine what output I'd like to look at. I'm going to come up here and I'm going to look at the deformation, and I'm going to look at the directional deformation. So you can see that's highlighted down here, and I can come down to the details of directional information, and I'm going to look at this on all bodies, The orientation, though, I want to be the Z-axis instead of the X-axis. I'll just leave it as mode 1 to begin with now. So that's all I need to look at. I'm ready to come up and hit the solve button and let this thing start to solve. You can see that I have a progress window showing up over here. If I want to stop it or cancel the solution, I can do that. You can see it solves those modes very quickly. It determined the first 10 modes. You can come over here, and in this tabular data, this damped frequency is the natural frequency associated with that mode. Now over here on directional information, you can see that's still the only output that's given. But if I come here and I select the top number and then scroll to the bottom and go shift click and click that entire column, then I can right click on that and go to create mode shape results. And when I do that, you can see over here where it has now automatically put in a total deformation for each mode shape. But you see that they have the yellow line, the yellow lightning bolts. So I need to come up here and I can either right click on that and hit evaluate all results, or I could come up and do a solve again. Either way. Now you can see I got green checks on all of those. I can scroll over here and there's my first mode. It occurs at a frequency of 831.6 Hertz. My second mode is at 1278.6, and you can just propagate through the different modes of your plate and see the associated frequencies. If I want to now take these values and bring them into MATLAB, all I need to do is click on the damped frequency, then right click again and say either export or copy cell. I can click on copy cell, and then I can go paste that into a notepad or a text file and read those values directly into MATLAB for further analysis. So that's how you do a modal analysis in ANSYS Workbench 18.1. I hope you've enjoyed the video and you find it helpful. Thanks for watching.